Welcome to part 2. Today we're going to be focusing in on the laws of nature. There's a common belief today that science has kind of done away with the need for God. It goes something like this. Our ancestors were bound by superstition. First they thought that spirits animated the natural world, and then they moved on to belief in gods of the earth, and then mankind developed beyond that to where we believed in a single God who was responsible for all that we saw in the natural world. But now with science we understand how things really work, and we really don't need God anymore. We've done away with superstition because we've replaced it with science. So that's kind of the common belief that I think many people hold today. What's kind of odd about that is that the idea of the laws of nature is really rooted in the Judeo-Christian belief in a supremely rational, all-powerful, transcendent creator. So that's kind of what motivated many scientists. They had good reason to do that in the Judeo-Christian belief in who God is and what he's like. And then the idea that you can apply mathematics to understanding the laws of nature, again, is rooted in the idea of man created in the image of God, and therefore being able to some extent, think like God and understand his ways to some degree. So it's kind of ironic in a sense, and so it reminds me of a story I heard a long time ago. It was about some critters who lived inside of Mozart's piano. Those critters had lived generation after generation enjoying the most beautiful music coming from Mozart's mind and hand as it floated through the air, and they always enjoyed it. And so the little baby critters would ask Mommy and Daddy, "Where's that beautiful music coming from?" And they said, "Oh, that's coming from the great composer." One day, Junior went off and did some exploring. He was an extra bold little guy, curious little guy, and he noticed these big long things that seemed to disappear in the distance. They turned out to be strings, and he noticed that when at certain notes, certain strings would vibrate. So he said, "Aha, that's where the music comes. It comes from the vibrating strings." And so he ran off to his mommy and daddy. He says, "Mommy and Daddy, I know where the music comes from. It's not really the great composer. It's really coming from these vibrating strings." And they said, "Oh yes, well that's great, but you know what? What causes the strings to vibrate? Surely it's the great composer." And Junior was happy with that, but the next day he went off exploring further, and then he noticed these great big padded things coming down out of the roof, so to speak, and hitting the strings. He noticed when they hit, the strings vibrated, and so he ran back to his mommy and daddy. He says, "Guess what, Mommy and Daddy? I discovered where the music comes from. What causes the strings to vibrate? It's those great big pads that come down from the ceiling. It's really not the great composer." And his parents said, "Well, yes, but what causes those hammers to come down? Surely it's the great composer." And so on and on this went as each day Junior went and explored a little bit more. And as you know, the inner workings of a piano are quite fascinating, as you have the hammers and pads and all sorts of stops and pins and stuff like that going all the way out to the keys and so forth. And so as he got more and more insight, he kept running back and telling his parents, and finally he convinced his parents, "You know what, there must not be a great composer. The music is just all these hammers and stuff hitting the strings and so forth, and that's what causes the music. There really is no great composer." So they settled down into that contented knowledge, and yet they weren't quite as happy as they were before. And yet all the time this most beautiful music was floating through the air as Mozart sat at the piano playing away on the keyboard. So the moral of the story is, just because you explain something doesn't mean that you explain things away. And that's the way it is with the laws of nature. There's a beauty and there's a wonder in the laws of nature that are hard to explain apart from God. They point to God. I'll give you some examples. So here we have Kepler's laws of planetary motion. Kepler lived in the 1600s, and he discovered that the planets went around the sun in an elliptical trajectory or path. So if you take an ellipse that has two foci, that's kind of how you define an ellipse, and at one of those foci was the sun, and the planet zipped around that, and Kepler discovered not only is it an ellipse with the sun at one of the foci, but also the planet swept out equal area in equal amount of time, no matter where it was on the ellipse. And lastly, he discovered there's a relationship between that long axis from left to right and the speed at which it went around the sun. And so there's this relationship now that applied to all the planets. If you knew the orbital parameters of a particular planet, you could predict how long it would take to go around the sun. And so Kepler's response to this discovery was wonder at the omnipotent God who created things in such a rational way and had given given man the capability to understand that. So he didn't see it as driving God into the shadows, so to speak. Rather, he saw it as pointing to God. Well, same thing with Isaac Newton. Of course, Newton is famous for his law of gravitation, but also his laws of mechanics. My favorite, force equals mass times acceleration. It turns out Kepler's laws are derivable from Newton's laws. And the wonder and beauty of Newton's laws is their breadth of application. We use them all the time at work. We use them in structural analysis to predict how stress will flow through a part, when the part will break, how it will deform, how it will shake. Our mission designers use the Newton's laws to design trajectories for getting to the moon and putting people on the moon and back. You can drive all that from Newton's laws. And then, of course, it's used to describe the flow of air around a wing and the flow of water through a stream and the motion of waves on the ocean. Just the depth and breadth and power of Newton's laws just has a real beauty about them. And then in 1915, Albert Einstein proposes a theory of general relativity as stated in his field equations. And those field equations relate time, space, matter, and energy. And those four quantities are tied together. It really shows up in the area of the very large on the scale of the universe and very high speed as you approach the speed of light. And that's where you really begin to notice the difference between that and Newton's laws, which are a special case of Einstein's field equations. General relativity has been described as the most beautiful of all the existing physical theories. And it's used in correcting the time codes that we get from GPS satellites. You have to take into account Einstein's theories when you're correcting the trajectory as your spacecraft are heading to the outer planet. And of course it describes black holes. So the depth and breadth of those equations is just incredible. And then there's the mystery of quantum mechanics, the laws of quantum mechanics. And here you see Schrodinger's wave equation. The predictions from quantum mechanics are very bizarre, shall we say, and very counterintuitive, but they apply at the very small level in a region of which we have no intuitive feel. And it turns out that the laws of quantum mechanics explain how atoms can exist. They explain the periodic table and the differences between the various elements. They explain colors, how color is produced, how we perceive color, how our eyes process the color and turn them into nerve signals for the brain. They're used in discerning the composition of stars that are light years distant. So the breadth of applicability of the laws of mechanics are just amazing. And finally, I want to discuss Noether's theorem. It's a mathematical theorem, and it basically says if your mathematical equations have certain characteristics, there's certain implications of that. And it turns out that these physical laws share this property called symmetry. So it turns out the law of conservation of energy really is manifesting symmetry with respect to time. And the law of conservation momentum is manifesting symmetry with respect to space. And so this whole idea of the beauty of symmetry is kind of a guiding principle for physicists these days. So how do physicists respond to this? I want to read to you a quote from a physicist who was interviewed by Scientific American. The physicist's name is Christopher Search. And here's what he said. Over the years, my view of physics has evolved significantly. I no longer believe that physics offers all the answers. It can't explain why the universe exists or why we are even here. It does, though, paint a very beautiful and intricate picture of how the universe works. I actually feel sorry for people that do not understand the laws of physics in their full mathematical glory because they are missing out on something that is truly divine. The beautiful interlocking connectedness of the laws of physics indicate to me how finely tuned and remarkable the universe is, which for me proves that the universe is more than random chance. Ironically, it was by studying physics that I stopped being an atheist because physics is so perfect and harmonious that it had to come from something. After years of reflecting, I simply could not accept that the universe is random chance. So the wonder and beauty of the laws of nature point to the omnipotent, all-wise Creator God. I also want to point out something else, and that's the utter reliability of the laws of nature. They really don't change. You can count on them, and we count on that all the time because you drive into your garage, you don't worry about the roof collapsing. You step on the ground and you don't expect it to give way. You rely on this consistency, and we rely on it all the time in engineering. When we design buildings and stuff, they're not going to change. Well, why are the laws of nature so reliable? Well, because the laws of nature is actually rooted in God's omnipotence. He spoke the world world into creation. And when he spoke, it came to be. And because God does not change, so the laws don't change. Now, if we do have some laws that change, well, it just means there are more underlying, more fundamental laws beneath them. And so it has to do with God's omnipotence and his omniscience. So I have this wonderful quote from the book of Jeremiah. So he's talking to a very discouraged people of Israel. They had expected to have a king on the throne. That king was taken into captivity. And so here's what God told them through Jeremiah. He said, "If I have not made my covenant with day and night, and established the laws of heaven and earth, then I will reject the descendants of Jacob and David my servant, and will not choose one of his sons to rule over the descendants of Abraham, Isaac, and Jacob." And of course, God did fulfill his promise, just as he said he would, and he did send his son to save the world. So you can count on the laws of nature, and I think it's kind of interesting. God's moral laws, we think maybe we can get around those as if they're any less certain. We have free will. We can choose whether to obey God and do what he wants us to do, or we can violate them. But there are consequences if we don't, and you can't get around that. When we do mishap investigations, something goes wrong, like a shuttle failure or a failure in a facility or something like that, we do a detailed investigation to find out what were the causes of the mishap, what went wrong. It never boils down to, well, the laws of physics are different, they changed. We never blame the laws of physics. It always comes down to human error. Somebody didn't understand how things work. Somebody didn't design something right. Somebody didn't make things right. Somebody didn't inspect something right. So failures always go back to human error, not to the laws of nature. So given the laws of nature, are miracles possible? Well, that's really a philosophical question, not a scientific question. You kind of need the laws of nature as a backdrop in order to give the word miracle any kind of meaning, because miracles are where something from the outside comes into nature and interferes with it, so to speak. It breaks the chain of cause and effect. So are they possible? Well, of course they are. They're possible for him who spoke all things into existence. So this picture of Jesus, he was with his disciples on the storm on the Sea of Galilee, and they were scared for their lives, and Jesus stood up and he spoke to the wind and the waves, and he said, "Peace, be still." Immediately everything became calm, and the disciples were just flabbergasted at the power of Jesus. And yet he was the one who spoke everything into existence. And so when he told them to be quiet, to be still, they had no choice but to obey him, and they quieted down. So you really can't take Jesus seriously without taking his miracles seriously. They go hand in hand, and he said his miracles point to him and to who he is. He is God's Son, the Son of God, and the one who spoke everything into existence. So I sometimes wonder when I contemplate the miracles of Jesus, what really happened there? I mean, what happened to all that energy and all that momentum when those waves ceased and when the winds died away? What happened to them? Did the big storm show up on the other side of the world, or they just kind of disappear altogether, or what? Or when Jesus healed the eyes of the man who was born blind, what happened? It's not just fixing retinas and nerve connections and stuff. There's reprogramming that has to go on in the brain so that when the man opens his eyes, he can perceive and understand what he's seeing. So it's just amazing what is involved in the miracles, and therefore that points to Jesus' power. And what about raising someone from the dead? Jesus raised people from the dead. Can you imagine what happened when he did that? And then he himself came back from the dead. So are miracles possible? Yes, they are, to him who spoke all things into existence. Now, given the laws of nature, does God answer prayer? And all I can say is that Jesus taught us to relate to God as our Father. And he told us to ask. And he said if we asked, we would receive. He said we could have confidence that he hears our prayers, and God delights to answer us when it is for our good. And of course, certainly you see examples of this in the Bible. So when I ask for something, am I asking God to interfere with the laws of nature, to frustrate those meteorologists to have the storm hold off, or what? So I don't know how it works, but I do know that we are to relate to God as our Father. And part of that is a relationship in which we ask and receive. And God the Father also asks and receives from us too. So it goes both ways. And I would like to say too that the most fundamental need that humans have, it's in the heart and it's in the soul. And I've seen many times where God did miracles in people's hearts and minds in answer to prayer, and where God displayed his supernatural power in transforming people from the inside out. Okay, with that, I'm going to move on to a slightly different topic, and that's the universe. Did the universe have a beginning? And of course, this has been debated throughout the ages. The Hindus believe in an eternal cyclical universe, so there's always been this debate. Judeo-Christian point of view says that God created all things, so he's the origin of all things. So what's the fundamental issue? The fundamental issue is to what or to whom do we owe our existence? If the universe has a creator, then we owe our existence to that creator. This picture is the Hubble Deep Field, the Hubble Space Telescope in space, stared at an empty patch of sky for on the order of 100 hours total. And this is what it saw. All those little fuzzy patches you see are actually galaxies. They're island universes. You see this inset of the Andromeda Galaxy. Andromeda Galaxy is our sister galaxy. So it's right next to us in astronomical terms, and it looks somewhat similar to us. You can see those lanes going around spiral form that are lanes of dust created by stars. You see all that fogginess. Those are unimaginable quantities of stars whirling around with planets around them. And of course, all the lights that you see that look like big stars, those are actually in our galaxy. We're looking through our galaxy to this distant galaxy, our sister galaxy, and the fog is made up of individual stars. And now we look at the universe as a whole, and we see galaxy after galaxy after galaxy on into the distance. And it turns out that the farther away the galaxy is from us, the farther away it is fleeing away from us in the younger it looks. And this points to a beginning of the universe. Okay, so before modern science, these arguments were going on, and the Kalam cosmological argument was one of those arguments about the universe having a beginning. It said basically whatever begins to exist has a cause outside of itself. Just kind of common sense, right? And then the universe began to exist. Well, how do we know this? Well, it turns out that there are certain logical contradictions that result if you assume that the universe is infinitely old. So if the universe began to exist, then the universe has a cause outside of itself. Who could that be, or what could it be? So if the universe has a cause, and an uncaused personal creator of the universe exists, who without the universe is changeless, immaterial, timeless, spaceless, and enormously powerful. But in the 1700s, a philosopher by the name of Immanuel Kant, sometimes called the father of modern cosmology, proposed that the universe was eternal. He felt that it made sense both philosophically and scientifically, that you had to assume that the universe had always existed, and if you didn't, it took the foundation out from underneath science. So basically he was pushing God off into the shadows, so to speak. The universe has always been here, but there were some problems with this that people pointed out. One of them is Olber's paradox. It was proposed by him in 1823 that if the universe is infinite in space and time, then the night sky should be bright, not dark like it is. And that's because everywhere you'd look at the night, you'd eventually bump into a star. So wherever you look, there'd be light. So that was one issue that was raised. Well, gee, what's the solution around that? Then there was Rudolf Clausius, who proposed in 1860 the law of entropy. It basically said that all things in a closed system tend toward disorder, and that's the natural flow of things. The universe is running down, and it's heading toward this endpoint called thermodynamic death. But it also means that if you go back in time, you reach a point of zero entropy, where you have supreme order, and that would mean the universe had a beginning. I remember a college professor told us, I think when he was talking about the law of entropy, he says, one thing I can tell you is that the universe had a beginning, and the universe will have an end. And I believe this is what he was referring to. But physicists, cosmologists really did not accept it, as still the prevailing view was that the universe was infinitely old. And then Einstein came out with his field equations. And well, one of the consequences consequences of the field equations that the universe is either expanding or it's falling back in on itself. Either way, it started out as a point. And so Einstein introduced something called the cosmological constant, and that's so he could show a steady state universe that was consistent with what cosmologists believed at the time. The problem is it didn't really conform to observations. And so we have this guy, Reverend Georges Lemaitre, who was a Roman Catholic priest and physicist and theoretician. He said the consequences of general relativity is that the universe must be expanding, and that would explain why nearby galaxies are moving away from us. And then Edwin Hubble used telescopes, spectrometers, to measure the Doppler shift of galaxies. He and Lemaitre came up with their law jointly. The galaxies are receding from the Earth, and it's approximately proportional to their distance from the Earth. So the farther the galaxy is away from us, the farther it's zipping away. And the implications are, of course, that as you run the video backwards, it all begins in a point. Everything comes back together. And that means the universe had a beginning. Well, how did this go over? It didn't go over well at all. Here's a quote from Arthur Eddington, a theoretical physicist of the last century. He said, "Philosophically, the notion of a beginning to the present order of nature is repugnant." Another gentleman by the name of C.F. von Weizsäcker, the physical chemist, he said, "The view that there might be an age of the universe is not science. The infinite duration of time is a basic element of all scientific thought, and to deny this would mean to betray the very foundations of science." So the theory received quite a bit of ridicule. In fact, the name Big Bang given to this theory was actually a derogatory term given by people who were skeptical of it. Well, one of the alternate theories was the steady state theory of the universe. Yes, the universe is expanding, but as galaxies get further away from each other, empty space opens up and matter spontaneously appears. And so the universe could have been expanding forever. So that was called the steady state theory of the universe. But in 1948, it was predicted that as a consequence of the Big Bang theory, basically as a consequence of nucleosynthesis, the combining of electrons and neutrons into hydrogen atoms as the universe cooled off shortly after the beginning of the universe, that this would produce a background radiation. So this radiation was first observed in 1965, and it was considered a major confirmation of the Big Bang theory, effectively killing the steady state universe model. So the Big Bang theory is pretty much universally accepted among physicists today. So what is the cosmic microwave background radiation, or the CMB? It's a wall of light emitted when the visible universe was 100 billionth its present size. That means you and I would be closer by a factor of 100 million than we are now. Unimaginably close. Because of it being so small, the temperature was extremely high. It's estimated to be 273 million degrees. But because we're fleeing away from it due to the expansion of the universe, it looks to us like it's only 2.7 degrees above absolute zero. So that means it appears to us in the microwave portion of the electromagnetic spectrum. And it's uniform in all directions to 1 part in 100,000. So if you had eyes to see down in the microwave region of the spectrum, it would look like this. Think of this as the Earth flattened out into the shape of the sphere. You've seen maps like that, except you're in the middle of the sphere and you're looking outward. So in a sense, we're looking at the universe as it's flattened out into a big oval, so to speak, and it would look uniform to your eyes, to 1 part in 100,000. NASA sent up several spacecraft to actually map the minute variations in this background, and they get a picture that looks something like this. There is variation, but they're very minute variations. From these variations, they can test various theories about what happened in the early stages of the expansion of the universe and infer certain things about the origin of the structure in the universe that we see today and so forth. So now I want to show you one other thing, introduce you to these gentlemen. You probably know Stephen Hawking, his co-worker Roger Penrose. They developed the Penrose-Hawking singularity theorems. And what they did is they proved that if general relativity is true, the cosmic expansion began from a point of zero volume containing all the energy and mass of the universe. That's called a singularity. So the implications of that is that space and time had a beginning. Not just space, but time itself had a beginning. So what would happen before the beginning of time? Well, that's beyond our ability to understand, but the time had a beginning, and so did space. And the Big Bang was, in fact, we think of a violent explosion, but in fact it was an extremely smooth expansion of space-time itself, space and time being coupled together. And it was an event of extremely low entropy, the exact opposite of black holes. Black holes result in extremely high entropy. And lastly, you look at the parameters that govern the universal constants that cover the rate of the expansion of the universe and so forth, that there's just a very narrow band at which the universe that we imagine today can even exist. And the fine-tuning that's required is 1 part to 10 to the 10th to the 123rd power. This is an absolutely unimaginably large number. It cannot even be physically written down in the universe. But that amount of fine-tuning is required in order to obtain the kind of universe in which we live. So what does that point to? Here's a reaction of a journalist who listened to a talk on this. I certainly didn't give it, but somebody much more knowledgeable than me. What if God is real, inexorable and majestic, impossible to escape? Not the wisp of hope you feel for a happy outcome when your airplane hits some turbulence, but the vertigo which you feel looking down on the Grand Canyon, which seems somehow to be sucking you in. So this points to a transcendent creator, someone that we cannot escape, someone who has knowledge beyond our wildest imagination, someone who has unlimited power, wisdom, and so forth. So it points to basically to the God of the Bible. But this can be a terrifying thought. Just think, you cannot escape God. There's no way. He's closer than breathing. So let me quote to you from Isaiah the prophet. He wrote around 700 BC. He said, "To whom will you compare me? Or who is my equal, says the Holy One? Lift up your eyes and look to the heavens. Who created all these? He who brings out the starry host one by one and calls forth each of them by name. Because of his great power and mighty strength, not one of them is missing." So God is so awesome. He's so terrifying in a sense because he's so big and we're so puny. We're less than a speck and a speck and a speck of the incredible universe, and that's just a speck compared to God. He's not even aware of us. How can he pay us any attention, answer our prayers, and so forth? And yet, that's not what Isaiah says. Why do you complain, Jacob? Why do you say, Israel, my way is hidden from the Lord? My cause is disregarded by my God. Is he too big to pay attention? If you think he's too big to pay attention, that means you think he's too small. Do you not know, have you not heard, the Lord is the everlasting God, the creator of the ends of the earth. He will not grow tired or weary, and his understanding no one can fathom. He gives strength to the weary and increases the power of the weak. Even youths grow tired and weary, and young men stumble and fall. But those who hope in the Lord will renew their strength. They will soar on wings like eagles. They will run and not grow weary. They will walk and not be faint. So God is outside of time. He's outside of this universe. And yet he is closer than breathing. He can hear you when you pray. He knows all your thoughts. So I say, you go to him. So next week, we're going to discuss the design of life. Thank you. While I wait for people to come in, I thought I'd like to explain this picture a little bit on the screen. So this is a telescope that I sort of finished making a few years ago. It's never really finished, but it's ground the mirror when I was in college. Well, many years later, after I got married and had kids, one of my kids who's standing behind me just on the edge of the screen on the right, his name is Joseph. He had read a book by Isaac Asimov on the inner planets, and he was enthralled with Venus, and he had read about this once-in-a-lifetime event that was going to happen in 2012 called the Transit of Venus. And so that year, he said, it's going to happen in June. He says, "Dad, could you finish your telescope so we could watch this event?" And I says, "Okay, well, I'll try." Well, it happened to be a very tough time for me. It was I was under a lot of stress and at work, and I was having some serious health issues. And I just felt I couldn't do it. I told Joseph, I can't do this. I'm sorry. We'll go watch it, but we can't watch it with a telescope. And he said, "Daddy, I'm going to pray." He was not giving up. And so I kind of felt like, well, gee, I better finish this. So somehow God gave me the strength to finish the telescope. But one of the things, you can see the little silver shield on the end. That's to keep your eye from burning out when you look through the telescope when it's pointed at the sun. Turns out there was a big run on those that year because of this big once in a time lifetime event. So I ordered the stuff and I wondered if it was going to come up in time. It showed up like a day early or so before the big event. So I quick ginned up a holder to put on the end of the telescope, and I finally on the day of the event in the morning, I took it out to look at the sun, and it was cloudy. It's like, oh my goodness, how on earth are we going to watch this once in a lifetime event when it's going to be cloudy? And the weather forecast, as I recall, was not that good for Cleveland. Well, wouldn't you know that the clouds just parted in time? I could test out my shield and everything worked. So we packed up the car and went down to Edgewater Park and got just wonderful views of the transit of Venus, and we had a big line forming behind the telescope of little kids wanting to take a look, and you'd see my toolbox down there that kids would stand on in order so that they could get high enough. So anyway, that's my story.